So 3.4, so finish up. We are about ready to do the studying the particle motion, example number 5. So example number 5. So pay close attention to this one because particle motion turns out to be one of their favorite AP tests subjects. So this comes out on the AP test quite often. Okay? So example number 5, in example number 5, it says we have a particle that moves along a line so that its position at any time is given by the function S of t is equal to t squared minus 4t plus 3. Okay. So A, find the displacement of the particle during the first 2 seconds. So displacement of the particle would be A. So at S of 2 minus S of 0, because S of 0 is where it actually started from. Time equals 0. This is time equals 2, right? So if I put time equals 2, where I get 4 minus 8 plus 3, so it looks like it's negative 1. And if it was 0, I get 3, so it's going to be 3. So the answer is going to be minus 4. Okay, in other words, it started at 3, and then it moved this way to minus 1. So it's minus 4. B, find the average velocity of the particle during the first 4 seconds. Average velocity would be nothing more than S of 4 minus sub 0, 4 minus 0, right? This is the what? Rise. This is the run, right? X equals 4, X equals 0, right? So this is the Y when X equals to 4 and Y when X equals to 0, right? X equals 4, I get 16, 16, so 16 minus 16, I get plus 3, and then I get negative minus S equals 0 is equals 0 is 3, 4 minus 0, 0 over 4 is 0. So it looks like it's 0. B, find the instantaneous velocity of the particle as t is equal to 4. Instantaneous velocity, so that's basically what? I'm going to go ahead and do S prime t. So if I do S prime t, I get what? 2t minus 4. And I want this one what? T is equal to 4. So S prime 4 is equal to 2 times 4, which is 8 minus 4. So it's going to be 4. That's C, then we go to D, find the acceleration of the particle when t is equal to 4. So the acceleration is going to be what? Double prime, so it's S double prime of t, which is the derivative of this, which is 2. So it doesn't matter what time it is, the acceleration is always going to be 2. That was D. Let's go to E. E, describe the motion of the particle. At what values of t does the particle change directions? So, this is the hard question. So we have what? Starts at 3. This is t squared minus 4t plus 3. Right? And this is going to be 1, this is going to be 3. Okay? So the particle starts at position 3. So it's going to start at 3. It's going to go backwards to at 2. At 2 we get what? 4. Oh, it was negative 1. So negative 1. So negative 1, right? So this is t is equal to 2. So it goes here at t is equal to 2. Then it's going to go backwards this way. So it's going to go this way like that. So it went this way and then turned around and went back that way. Okay. So at at what values of t does the particle change direction? So it's going to change direction right here. So it's going to be what? T is equal to 2. When t is equal to 2, it goes from going to the left back to the right. F, use parametric graphing to view the motion of the particle in the horizontal line. So parametric, you would say what? You have S, so X is going to be just equal to T. Y is going to be equal to T squared minus 4T plus 3. So X1, Y1, this is how you would put in your parametric mode, and you would graph it, and you would see it do the same thing here. Okay. Okay, so that's that. Let's now go to page 135, sensitivity to change. Sensitivity to change. So how sensitive are you when the other thing changes? Okay, that's basically what it's saying, right? Sensitivity to change. So this is on page 135. In the middle, it says, we introduce sensitivity in section 2.4 as a measure of how change in one variable affects the change in another variable. The derivative gives us an easy way to compute this sensitivity. Example 6, it says the Austrian monk Gregor Johann Mendel. Okay. So you guys done this, right? P's in biology. What is it called? You have the dominant, recessive, and all that good jazz. You guys remember doing this? You had P1 minus P, P1 minus P, because this is the probability of having a smooth, this is a probability of having a wrinkled one, I think. Is that what they're doing here? Smooth and wrinkled? Yeah, smooth skin and wrinkled skin. Right, so this is going to be P squared. This is P times 1 minus P. This is P times 1 minus P. This guy here is 1 minus P squared. So which one here is going to be smooth? Kayla.
The one in the bottom right corner.
The bottom right here?
Yeah, I didn't.
This is going to be the wrinkled one, right?
Oh, then the top left.
This is the wrinkled one. This is the wrinkled one. This is smooth. What about this one? If you have the dominant and the recessive together, it's going to give you the dominant trait, right? Remember that? You guys didn't do this in biology? You guys haven't taken biology yet?
That was a while ago.
Oh, it was a while ago, so we already flushed it. Is that what we're saying? Okay,
Kinda.
so if you have a dominant and recessive together, the dominant is going to show up, and that's why it's called the dominant gene, right? Okay, so you have dominant, dominant, dominant. You're going to have recessive here. Okay, so this is the only one that's going to be wrinkled. Everything here is going to be smooth and smooth and smooth. Okay, so if you added up the smooth, what do you get? You're going to get smooth here, which is P squared. And then you're going to add this guy, which is P times 1 minus P. And you have two of those, right? You have two of those. Think this is how it works? Or what are they asking for? Oh, they're doing just these two. They're doing just these two. So it'd be 2P plus 1 minus P. So it's going to be what? If I add these, I get 2P minus 2P squared. So the sensitivity to the change, all right? So as the P changes, how is this going to change with it is nothing more than the derivative of this, which is going to be 2 minus 4P, it looks like. Okay. So moving right along, we get derivatives in economics. If you flip the page, this is not as, well, it depends, I guess. Depends on your point of view. For me, it is not that interesting, but for some of you, it could be if you're going to go study economics or anything of that nature. Okay. You go here, it says, when you're manufacturing something, okay, there's something called the marginal cost. And the marginal cost is if you are given C of X, which is, okay, where are we at? Suppose C of X represents in the dollars needed to produce the amount. So this will be the cost of an item, right? And then once you manufacture the cost, you're going to get what is called a revenue, right? You're going to sell it and make money off of whatever you do, right? Okay. So if you look here, it says, so this is the marginal. So the marginal cost is nothing more than C prime of X, where the marginal revenue would be the R prime of X. So marginal cost, the definition of it from economics is that the additional money it takes to produce when you are actually producing one more. So it is basically the delta of the cost when you are the delta of the X, right? So if you change, but if you increase the number of things that you're going to produce by 1, how does the cost change? Okay, so this is that. Whereas this is going to be the marginal revenue, which means that it's the same thing. The revenue, how the additional revenue you're going to generate by selling one more widget or whatever else you're selling, right? Okay. So in example number 7, it says that marginal cost and marginal revenue. Okay, suppose it goes blah, 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 blah. So, okay, so let's go ahead and do this. Example number 7 says, suppose it costs C of X. So we have C of X is equal to X cubed minus 6X squared plus 15X. We have the revenue is equal to X cubed minus 3X squared plus 12X. Okay, so find the marginal cost and the marginal revenue. So the marginal cost is going to be what? Nothing more than the derivative of X, C of X, so it's going to be 3X squared minus 12X plus 15. The marginal revenue is 3X squared. Now I'm taking the derivative of this guy here, 3X squared minus 6X plus 12. Okay, and is that all we're doing? That's all we're doing? Okay, your shop currently produces 10 radiators a day. So if I put 10 into here, what am I going to get? So in other words, if I put 10 into here, I'm going to get 300 minus 120 plus 15. So that's what, 180. So that's going to be 195. If I put the 10 in here, I'm going to get 300 minus 60 plus 12. 240, so 252. Okay. And so that's that. Okay. And we are done with 3.4. Okay, so we're done with 3.4.